What's up? I'm Vin, and today I want to go through the New York State Grade 8 math test from 2023. I'm going over the released questions, and if you want to follow along, I will leave a link to a copy of this test in the description below. Now, question 1 was not released, so we're going to start here at question 2, and we have which scatter plot best represents a linear association between y and x. So when you hear the phrase linear, just think of line here, and if we look at choice A, notice this would be an exponential association here, that if I connect these points here, you see how it's making this curve here. So this is not forming a line, so A is out. Now B, there's no association between y and x. This is all just random points here. So we could just go ahead and chop out choice B. And now choice C, this is definitely not forming a straight line. This is kind of looking like a parabola here, so this one's out. And now choice D, if we draw our line of best fit, you see how this captures most of the points here. So choice D is our solution. So question 3, we have quadrilateral ABCD. It's graphed on the coordinate plane, and we have vertex A is located at the point -2, 3. And then the quadrilateral is dilated by a scale factor of 2. The center of dilation is the origin, and we're forming our new quadrilateral, A prime, B prime, C prime, D prime. We want to know which ordered pair represents the location of A prime. So for this one, if you just want to know how to use the formula, our point A is at -2, 3, and we're dilating this point by a scale factor of 2. And all we have to do if we just want to use the formula is multiply the x and y by the scale factor. So I'm doing -2 times 2, that would give me -4, and then I'm doing 3 times 2, which is going to give me 6. But now if you want to know a little bit more about the concept here, when you're dilating something, it's the same idea as when you take an image and you just drag the corner out to make the image bigger. You can still recognize this picture as a piece of delicious broccoli, but if I were to scale this by a scale factor of 2, it would essentially double the distance between all the corresponding points on this piece of broccoli. And if I had a scale factor of, let's say, a half, that would cut this down in size like this. So what's going on in this actual question here is that when we start at the point -2, 3, so this is the location here of A, and our center of dilation here is the origin. When we scale this out by a scale factor of 2, when we wind up at the point -4, 6 here, essentially what it's doing is it's taking this distance from A to the center here being at 0, 0, and it's doubling it to extend it out another distance here that's equal to this original distance from, let's say, point O to point A. So we're just doubling the distance, and using this formula of just multiplying each coordinate by the scale factor tells us where our new location A prime is going to be. But in either case here, our answer is going to be choice B. So next up, question 7, and we have the equation and table shown below represents a different relationship between x and y. So we have function A and function B, and we want to know which statement about the functions is true. And notice what we're looking at here is the rate of change for all of these answer choices here. So that tells us we have a linear function for A, and the way I know this is that it's in the form of y equals mx plus b, where m represents the slope and b represents the y-intercept. So when your function is in this form here, your linear function, the slope is the rate of change, and that's the number in front of the x, which in this case is going to be 5/4. Because once again, notice this equation is in the form of y equals, and we have a number times x, and technically our y-intercept here is 0 because there's an invisible plus 0 after this, but all we care about is the slope, the rate of change. So the rate of change for A, we'll just write off to the side here, is 5/4, which is the same thing as 1 1/4, or 1.25. Now for function B, if we want to find the slope, notice that we have multiple points. We're going to use this formula. We have y2 minus y1 over x2 minus x1. So think of this one here as like your x1, y1, and then this point over here could be our x2, y2. So then we're just going to plug this into the formula for slope. So our slope is going to be, we're going to have y2 minus y1, so we have 3 minus 1.5, and then we're dividing that by, we have 10 minus 5. And 10 minus 5 is going to go on bottom here, and now we just simplify, that's going to be 1.5 over 10 minus 5 is going to give us 5. And if I want to make this into a nicer fraction here, all I could do is multiply the top and bottom by 2. And now 1.5 times 2 is 3, over 5 times 2 is going to give us 10. So this simplifies here to 0.3 if we want to write this as a decimal. So you have 3 over 10, or in other words, we could say 0.3. So now just looking at this, we could say that A clearly has the greater rate of change. So when we scan the answer choices here, function A has a greater rate of change than function B, because the slope of A, we said, was 1.25, and that is greater than the slope of B, which was 0.3. So that definitely checks out. Choice C is our answer. Now, before we move on here, let's say you had no idea what to do with a question like this. You could look at choice A and see that 1.25 greater than 3.3 repeating is an obviously false statement. So that eliminates choice A right away. And then if you look at the remaining answer choices here, if you look and see 1.25 is less than 0.3, this is not true. Okay, so since this part of the answer choice is not true, we could eliminate choice D right away. And that would leave us with just choices B and C. Of course, here, if you had no idea what to do, you'd have to guess and pick the correct one. And in this case, choice C would be correct. So question 8, we have 2 points plotted. Point A is plotted at -11, 8, and point B is plotted at -2, -4. What is the distance in units from point A to point B? So there's many ways we could do this question, but I would say here having a visual understanding of what's going on will be very helpful. So -11 would be, we're going to the left 11, and then we're going up 8 like this. So this is going to be the point here for point A. And then point B is located at -2, so that'd be -2, and we'll say -4 is somewhere down here. Okay, so this is not necessarily drawn to scale. This is just to give us an idea of what we're looking for. So we want to find the distance between points A and B. Now, if you forget the distance formula, one thing you could do here is draw a right triangle like this. So I would drop down the vertical leg like this, and then I would drop down the horizontal leg to get me from point A to point B like this. And then all you'd have to do here is count the space. Or if you want to be clever here, you could just subtract. So notice that this was the location. Let's just clean this up. This was the location here of -11. Okay, so now that that's out of the mix, we're at -11, and we're going all the way across to -2. So you could count the spaces. But just think about it. How far away is -11 from -2? That's a distance of 9. Okay, so what I'm doing in my head is I'm doing the number on the right minus the number on the left. And that would just give us here, we'd have -2 plus 11, which would give us 9. So that's how I know this is a distance of 9. Now, same thing for the vertical leg. I could count the boxes going straight up, and I would be counting from -4 up to 8, or I could take the number on top and subtract the number on bottom, and that would give me 8 plus 4, which is equal to 12. Okay, so then this leg here would be 12 units long like this. Okay, so that's just one way to do this. If you know your distance formula, of course, you could always just use this formula here, and this would answer the question in one shot. But I'm pretending that we forgot this formula, or this formula confuses us. Okay, so we could plot the points, draw in a vertical line and a horizontal line to connect them like this. But just make sure that you go the most efficient way. You just go down once and over once, and then just label the distance that you found. So now from here, we could use the Pythagorean theorem to find the length of this hypotenuse here. So let's say I call this hypotenuse, we call it length C like this. Let's just make that a little bit neater. So we're calling this distance C. Then what I would have is, I would have, remember the formula, a squared plus b squared is equal to c squared. And in this case, we'll say that a is equal to 9. And we'll say that b, lowercase b, is equal to 12. And that would give us 9 squared plus 12 squared is equal to c squared. So now we would have 81 plus 144 is equal to c squared. And when you add these two numbers, you're going to get 225 is equal to c squared. And now for this, you just do the square root of 225. Okay, so we're taking the square root of both sides, and c is going to be equal to 15, because 15 times 15 is 225. So choice B would be our solution. Now, there's a really clever way to do this. If you know your Pythagorean triples, these are just standard triangles here that show up a lot. And one that shows up very commonly would be the 3, 4, 5. And when I look at this 9, 12, I think of similar triangles, and I'm thinking, okay, scale factor of 3. If I scale this up, okay, using concepts of similar triangles here, if I were to multiply each side by 3, 3 times 3 would give me 9, 4 times 3 would give me 12, and 5 times 3 would give me 15. And you see that that gives us the missing side as well. This way is definitely more slick, but both ways will get us the correct answer, choice B. Question 12, the rule for a function of x is we multiply the input value by 2, then we subtract 6. Now just remember, if it's a function of x, the input value is x. So our equation here we could say is y equals, we multiply the input value x by 2, so that would be 2x, then we subtract 6, so we'll tack on minus 6. And we have the data set for the input values of the function x is -1, 1, 3, 5. So essentially what we're doing here is we're making a table of values, x and y, but they're telling us to use these values of x that's in this data set here. And which value is one of the output values for y? So for this one here, we could just use a calculator. So for something like this, I would just go to the y equals and I would type in, we have 2 times x minus 6. And if we want to pull up a table here, we could press second graph. So this is if you're using a Texas Instrument TI-84, and this is the TI-84 plus CE. And remember, we had to plug in -1, 1, 3, and 5. So we just need the table here to show those values of x. So after looking at that screen on the calculator, I would just transfer everything. At -1, y is equal to -8. When x equals 1, y is equal to -4. And when we have x equals 3, y is equal to 0. And at x equals 5, y is equal to 4. So then we just scan the answer choices here for one of those y values. And it's looking like the last answer choice here, D, that y equals 4, would be the result of plugging in x equals 5. Now, just know that you could do this by hand. Like, let's say here you wanted to take x equals 5 and plug it into the equation. You would have y equals 2 times 5 and then minus 6. And that would give you y equals 10 minus 6. And 10 minus 6 is 4. And you see that would be one of our output values. So choice D is definitely correct. So question 15, we could just type in the question and then all the answer choices and see which ones match. But I'd rather do this by hand here so that we really understand the exponent concepts. So 16, what jumps out at me right away for 16 is that 16, if we were to break this down, is 4 times 4. And if we were to break this down even more, this is 2 times 2 times, and then we would have another 2 times 2. And I'm just breaking this down as much as possible. And then if I multiply 2 by itself 4 times, that's 2 to the 4th power. So what this tells me right away is that 1 over 16 is the same thing as 1 over 2 to the 4th power. So one of the laws of exponents here tells us that when we have a to the negative b power, we could rewrite this as 1 over a to the positive b power. So we essentially just flip the base and it makes the exponent positive like this. So that's just like a nice little piece of math that you should know here. And what that allows me to do is I could rewrite this 1 over 2 to the 4th. Now I could write this as 2 to the negative 4. So this is essentially what I'm looking for in the answer choices here. Now, some other rules that you need to know here is that when you multiply something like a to the b times a to the c, that would give you a to the b plus c, which is not necessarily showing up here. But what we do have is when we have a power raised to another power, in a situation like this, you would multiply. You would have a to the b times c. So I'm looking for any answer choice here such that we all of them have a base of 2. So far, so good. But which of these, when you multiply the two exponents together, gives you an exponent of -4? Well, this answer choice is no good because that would give you 2 to the positive 4. Because -4 times -1 is positive 4. So this is out. Choice B looks good. We would have 4 times -1. So our exponent of 2 would be 4 times -1, which is -4. So this is looking good. This choice is no good because 8 times -2 would give us an exponent of -16. And then this one's no good because that would give us an exponent of positive 16. So choice B is definitely our solution. But once again, if you just want to use a calculator to answer this, what you could do is you could write in 1 over 16. And you could either remember this decimal here, and then you type in the answer choices. And notice that if I put a parenthesis here, I have 2 to the 4th power. And then I'm going to get out of that exponent by hitting the right arrow. I close the parenthesis, and then I raise all of this to the -1. And notice that I get a matching decimal here. So choice B is definitely correct. Question 16, we have a cylinder has a radius of 4.8 feet and a height of 8.1 feet. What is the volume to the nearest tenth of a cubic foot of the cylinder? So first we have to know that the volume of a cylinder is pi r squared times h. So if I were to just draw something out here and look at this, so let's draw a better circle than that. So here's a circle, but now I'm going to extend this down like this so I can make a nice cylinder. So here's our cylinder. So this is what a cylinder looks like. It kind of looks like a can of soup. So what we're told is the radius is 4.8 feet. So that would be the distance from here to here. So 4.8 feet. The distance from the center of the circle on top or bottom to any point on the circumference. And the height, so this is our radius, is 4.8. Our height is going to be equal to 8.1 feet. So then all we have to do here to find the volume is plug into the formula. So we would have the volume equals pi times, and then the radius is 4.8. So we have 4.8, and that's being squared. And then we're multiplying by the height, which is 8.1. And the units here are cubic feet. And cubic feet you write as feet to the 3rd power. Now, this is just multiple choice, so writing the units doesn't matter. But later on in math, units are definitely very important to include in your answer. So this is what we're going to be typing into the main screen. So we're on the main screen of the calculator. If you want pi, press second and this up arrow here, and that's pi. And then we have parentheses 4.8 squared. So I close the parenthesis and square it. And then I have another parenthesis, and I'm going to write an 8.1. Now, just remember, in math, parentheses mean multiply. So the calculator is going to know to multiply everything. And that would give us our solution here. Now, I know we have to round our answer choice here, but lucky for us, choice B is the only one that's in the neighborhood of this number. But if we had to round this by hand to the nearest tenth, the tenths place is right after the decimal to the right. And if we look at the tenths place and we look 1 unit to the right like this, notice it's a 9, which is higher than 5. Or if it's a 5 or higher, we round up. So that would give us 586.3. So choice B is definitely our solution. So question 19, we have triangle ABC over here in quadrant 4, and its image, triangle A prime, B prime, C prime, is over here in quadrant 3. And what we want to do is find the sequence of transformations that maps triangle ABC onto triangle A prime, B prime, C prime. So we want to follow the transformation so that this triangle falls exactly on top of this triangle. Now, right away, I could see that we're going to be reflecting first because every answer choice says reflection. But I know we're not reflecting over the x-axis, because if we were to reflect this over the x-axis, triangle ABC, notice point A, I would have to go up 4 units to get to the x-axis because I'm down here at -4. I'd have to go up 2 and up another 2. So then for me to reflect this properly, I would have to go an equal distance across the x-axis. So I would have to go up another 4 units like this. And then notice what we have here. This would be our mirror image of triangle A prime, B prime, C prime. But then after we reflect over the x, we're either translating left or right. But the problem is if I go left or right, there's no way I'm going to be falling on top of this triangle A prime, B prime, C prime. So the choices C and D are out. But if we use the reflection over the y-axis first, now I'm going to the left first. I'm going to the line of reflection, the y-axis, and whatever distance it takes me to get there, I have to go the same distance across. So here, if I'm starting at x equals 4 for point A, I go to the left 4 units, and then I go to the left another 4 units. But then you could see here, which direction do we have to go? Am I going to go up or down in order to fall on top of this triangle? I would have to go 2 units up like this, and notice this triangle would go perfectly on top of that triangle. So this tells us here that we're going to reflect over the y-axis, and we're going to go 2 units up. So question 20, we want to know which equation represents the graph of a line on the coordinate plane that passes through the x-intercept at 9, 0 and the y-intercept at 0, -5. So for this one here, I think the best way to do this would be to use the formula y equals mx plus b. And what I'm imagining here is that if we have this graph of these 2 points, we have 9, 0 is, let's say, all the way over here. And then we have the point 0, -5, which would be over here. So this would be our y-intercept. So we have our x and our y-intercept. So the equation we're looking for is the equation of the line that connects these 2 points like this. So what this means, the b value is your y-intercept. And our y-intercept here, the line is crossing at -5, so our b value would be -5. Now m is our slope, which is another way of saying it is our rise over run. Okay, so we're going to look for the rise over the run. And if you want to just use the graph here, think how far do you have to go up? You have to go up 5 units. So if I want to go from this point to this point, I'm going up 5 units. So my rise, I'm rising 5. So I'm going up 5 to get to here. And then I'm going to run 9 units to the right. So my run is going to be 9 units going to the right like this. So then my slope is just going to be 5 over 9 like this. So now I have both pieces here for my line. So just plugging into the formula, y equals m would be 5/9, and then we tack on the x, and then plus b is -5. So we're looking for 5/9 x minus 5, which would be choice D. Now, let's say you don't like rising and running this way using the graph. You could also find the slope by using this formula, y2 minus y1 over x2 minus x1. And if you do it this way, just call this point, let's say x1, y1, and you call this point here x2, y2. And if you use the formula, then you're just going to plug in. You have y2 is -5 minus y1 is 0 divided by, and then we would have x2 is 0 minus x1 is 9. And then this would work out to -5 over -9, and then this simplifies to positive 5/9 like this. So either way, we would get a slope of 5/9, and our b value would be -5, giving us choice D. So question 22, we have Trent draws a triangle with one interior angle measuring 34 degrees. Which angle measures could be the measures of the other 2 interior angles in Trent's triangle? So for this one, you have to know that for any triangle, the sum of the interior angles is 180 degrees. So if one of the angles is 34 degrees, the other 2 angles, if you call them, let's say x and y, would have to, with 34 degrees, make 180 degrees. So that would mean x plus y plus 34 would have to equal 180 degrees. So if I want to know what is the sum of the other 2 angles here, I would just subtract 34 degrees from 180 degrees. And now if we work this out, this tells us the sum of the other 2 angles would have to equal, this would work out to I could use a calculator, or we could just do the long subtraction here. This is going to work out to 146 degrees. So what we're looking for here is that the sum of these two angles has to equal 146. Well, if you add these two, 46 plus 90 is 136. So this answer choice is no good. If we add these two angles together, 53 plus 127, that's going to work out to 180 degrees, which would give you all the angles of the triangle all at once. So then you wouldn't even have a third angle. So this would not even be possible for any triangle in 2 dimensions. So choice B is out. And now if I add these two, 66 plus 80 is going to give us 146. So choice C is looking good, but let's just be sure and eliminate choice D. If you were to add 68 plus 68, this would give you 136, which would be too little. We wouldn't have enough degree measure inside there. So then choice C is definitely our solution. So question 23, we have a whole lot going on here. We have Nathan observing sunflower plants, and he's collecting data on the relationship between the height in centimeters of each sunflower during a 30-day period and the amount of fertilizer in grams used on each plant. So we have the equation for the line of best fit for this data is here. So there's our equation of a line. And this is very important here. Y is the height of each plant in centimeters. X is the number of grams of fertilizer used. So what I'm imagining right away to help us out with this is we have X, and we're told once again, X is the amount in grams. So X is telling us grams, and Y is telling us the height in centimeters. So I just want to label the axis here so that when we start to answer this, that we have a good idea of what each part of the graph represents. So based on this model, what does the slope of the line represent? So the line was y equals 0.35x plus 2. So the slope here is 0.35. So that's our slope. But we have to think about what do the units represent? Because if I just give a rough sketch of this line, like we have a y-intercept of 2, and we have a slope of 0.35, so that would be something looking kind of like this. When you're looking for the slope of a line, you're looking for the rise over the run, or we could think of it as y2 minus y1 over x2 minus x1. But one thing to pay attention to here is that the units on top here correspond to the y units. So notice that our slope is 0.35, and we would have centimeters on top because the y is on top and the y units are centimeters, over the x2 minus x1, the x units are grams. So now I would scan the answer choices here to see, once again, what does the slope of the line represent? The height of the plant would be no good because this would represent the meaning of the y term. The amount of fertilizer in grams would represent just the x. The average amount of growth of the plant per gram of fertilizer used. But once again, the growth was in centimeters and the amount of fertilizer was grams. So centimeters per grams is matching up. Choice C is looking good, but let's see why choice D is no good. So we have the average amount of fertilizer used per centimeter the plant grew. So the amount of fertilizer used would be grams, and then per centimeters would be no good, because this would be if we messed up the slope formula and did x2 minus x1 over y2 minus y1. But that's not the slope formula, so that's why choice D is out. Choice C is definitely our answer. So question 24, we have line segment CD graphed on the coordinate plane, and the line segment is first reflected over the x-axis, and then it's rotated 90 degrees clockwise about the origin to create line segment EF. And we want to know which statement is always true about line segment EF. So what I'm imagining in my head here is we have the XY axis, and we don't have to be super precise here, but we have some line segment which we can name CD. And the first thing that's happening is we're reflecting it over the x-axis. So this is not necessarily drawn to scale, but here's the new line segment like this, reflected over the x-axis. And then from here, it's rotated 90 degrees clockwise. So if you imagine a clock here, 12, 3, 6, 9 like this, we're spinning in the direction of a clock that actually works. Okay, so if you have a clock, and let's say you have the minute hand and the hour hand, the hands are going to be spinning in this direction here. So now I'm taking this thing and I'm spinning it in this direction, 90 degrees clockwise about the origin. So it's as if I'm connecting this point to this point here, and then I'm spinning 90 degrees, let's say in this direction. But the big idea behind this is that, for one, when you reflect a line over the X or Y axis, or any line for that matter, the line that you get in the image here does not change in length. That original line is going to be congruent to the new line like this. And also, I drew this off to the side like this so you could see that if I spin something, spinning something doesn't change the size of it. It's still going to be congruent to the original shape like this. So what that tells me right away is that if I'm reflecting, I'm not changing the length of the line. If I spin the line right after, that's also not changing the length of the line. So that's telling me right away that the new line segment EF is going to be congruent to the original line segment CD. So choice A is definitely our solution. Question 25, we have this figure here, and lines A and B are parallel. So that means these two lines will never intersect. And line C is a transversal. We want to know what is the value of X. So just know anytime you have parallel lines cut by a transversal, the corresponding angles formed are congruent. So what I'm noticing right away is 11x plus 30 is in the same location in this section as 13x plus 6 is in this section. They're both in the upper left section here. So that means since they're in corresponding locations, we could set these two expressions here equal to each other because these two angles have to be equal in measure. So I'm going to set 13x plus 6 equal to 11x plus 30, and now I'm going to solve for x. So here I'm going to subtract 11x on both sides to get all the x's on one side. And now 11x minus 11x cancels. 13x minus 11x is 2x. I'm just subtracting the coefficients. I'm doing 13 minus 11, and then the x just tags along. Now this plus 6 will just follow down here like this, and we're left with a 30 on the right side. Now I'm just going to do minus 6 on both sides to get rid of that plus 6 on the left. And now 6 minus 6 cancels. We're left with 2x equals 30 minus 6 is 24. And now we just have to divide both sides by 2 to get rid of that 2 in front of the x. And that tells us x is equal to 24 divided by 2, which is 12. So x equals 12. Choice C is going to be our answer. Now for this test, I bet there were plenty of students that took 13x plus 6 and they added it to 11x plus 30, and then they set this sum equal to 180. But be careful, this is a very dangerous bear trap. If 11x plus 30 was, let's say, written in this location here, so let's say it was moved to this location, then what we wrote in red would be valid here because these two angles would be forming a straight line. But this is not what we need to do here. We have to do this method over here. And if we follow this through, 13x plus 11x is 24x. And if we do 6 plus 30, that's 36. If we go ahead and work this out, I bet there's going to be an answer choice waiting for us. So we just go ahead and subtract 36 on both sides. 24x is equal to, this works out to 144, and then divide both sides by 24 like this. And this is going to tell us that x is equal to 6. But remember, this is not the move we want to do here. See, choice A is actually a dangerous bear trap. Okay, so we have to be on the lookout for things like this. Make sure you think carefully before you set up your equations. Question 26, we have two functions are described below, function A and function B, and we want to know which statement correctly compares the relationship between function A and function B. Well, just know in general, this equation is very useful. We have y equals mx plus b, where m is the slope, and in the context of word problems, slope is the rate of change. So we have the rate of change. If we're talking about a graph, the slope is the rate of change, but we are especially looking for that phrase in this question here. And then B is the y-intercept, and the y-intercept represents the initial value. Okay, so that is our initial value. So now we go ahead and read this. We have function a taxi driver charges customers a base amount of $3 and also an amount of $2 per mile X. So just know here that this phrase, the $2 per mile, represents the rate, and the base amount of $3, this is the initial value. So this will allow us to write an equation for y. Y equals our rate, or our slope, is 2. So we have 2x plus the base amount, or the initial amount, is $3. So we have the equation y equals 2x plus 3. And they were very polite. For function b, we have an equation y equals 3x plus 2. So now we just have to identify a few things. The rate of change for function a and b. Well, the rate of change is just the coefficient of x, and that's going to be 2. And then for function b, the rate of change, the coefficient of x, is equal to 3. So that's going here like this. And now we're just going to talk about what is the initial value. So the initial value here for function a is the constant at the end. That's equal to 3. And then the initial value for function b is the number at the end here, the 2. So now we just scan the answer choices, and choice D is looking good. We have function B has a greater rate of change than function A because 3 is greater than 2, but the initial value for B is less than the initial value for a, since 2 is less than 3. So choice D is definitely correct. So question 29, we have triangle ABC, and it's undergoing a sequence of transformations to create triangle A prime, B prime, C prime. And we want to know which sequence of transformations could have been used to take this triangle ABC to triangle A prime, B prime, C prime. Now for this question here, you might just be able to do this in your head, but notice every single answer choice starts out with dilation. But the only thing that's different is that for the first two answer choices, the scale factor is 2. And for the last two answer choices, the scale factor is 1/2. And if you think about this logically here, a scale factor of 1/2 would make this triangle smaller. So that would, once again, these would make triangle ABC. This would make it smaller. But notice that triangle A prime, B prime, C prime is bigger than the original triangle. So that's how I know right away that these answer choices are out. So the scale factor would have to be 2. And then think about this. Once the triangle grows, so you have a bigger triangle, does this have to be flipped over the x-axis or over the y-axis? And you could see that when we grow this triangle, it's going to grow in this direction here, and we would have to flip it over the x-axis to map it onto this one. So choice A right away, just by doing this in my head, is looking good. But if we want to be really precise here, we could take ABC. So point A is at 2, 4, and then point B is at 2, 2. So we could take all of these points here for A, B, and C, and we could run it through the dilation. So the dilation here is a scale factor of 2, and that would send us to these points here. So this would send us to, if we double this, it would send this to the 0.48, and then that would send this to the 0.44, and this would send C to the 0.12, 4 like this. And if I plot these points, you could see 4, 8 sends us up here. So this would be, I'm not going to call this A prime because A prime is going to be down here in a moment. So the almost B prime would be 4, 4. And then almost C prime would be at 12, 4 like this. So now you see this triangle over here. If I took this triangle and I flipped it over the x-axis, you see how that's going to land perfectly on top of this. And if I really want to be sure here, just count the boxes. I have to go 1, 2 spaces to get to the x-axis, and I have to go another 1, 2 spaces to get to the point C prime. Now, technically I'm counting by 2s, so I'm going 4 spaces to get to the x and another 4 spaces to get to C prime, but I just meant we're counting the number of grid spaces on the graph here. And that would work for the other points too. If I took almost B prime and I went down 1, 2 jumps like this, it takes another 2 jumps to get to this point. And from this point, I have to go 1, 2, 3, 4 jumps, and then I have to do 1, 2, 3, 4 jumps to get here. So choice A is definitely correct. So question 33, we have the graph of a line is shown on the coordinate plane below, and we want to know which equation represents the graph of the line. So this formula is very useful. We have y equals mx plus b, and just know that m once again represents the slope and b represents the y-intercept. But when you're given the graph of a line, the way I like to find slope is I like to look for the rise over the run. I could use the formula that I wrote before, the m equals y2 minus y1 over x2 minus x1, or I could just take this point here and I could count the number of boxes I have to rise and run to get from one point to the next. So notice I have to rise 1 unit. So I'm going to rise 1 and I'm going to run 1, 2 units like this. So my rise over run is 1/2. But once again, if you'd like to use the formula, you take these 2 points, 0, 1, and then you have this point here, 2, 2. And you could go ahead and use the slope formula, and that's going to give you the same exact slope that we got a moment ago. So if I use the formula, we have y2 minus y1, that's 2 minus 1, over x2 minus x1, and that would give me 2 minus 0. This would also simplify to 1/2. And just know I could pick any 2 points that I want. Let's say you wanted to pick this point and this point out here. These are incredibly far away, but if you found the slope between those 2 points, it would also equal 1/2. And now the b value is the y-intercept. That's where the line crosses the y-axis, and it's crossing the y-axis at the point 0, 1, but it's specifically touching the y-axis at a height of 1. So that would be my b value. So my b value is 1. So now I just plug my m and my b value into the formula mx plus b, and I would have y equals m is 1/2, x plus b is equal to 1. So I just scan the answer choices here, and choice A is our solution. So question 34, we're finding rates of change yet again. So we're going to use this formula, m equals y2 minus y1 over x2 minus x1, because we have to compare the rates of change of function A and function B. So looking at this, I could pick any 2 points that I want. So I'll go ahead and pick the points that the numbers are the easiest. I would rather pick 0 and positive numbers than work with these negative numbers here. So that would mean I'm using the point 0, 0, and the 0.24. So this is going to be my x1, y1, and this is going to be my x2, y2. So if I find the slope of function a, I'm going to have, we have y2 minus y1, so 4 minus 0, divided by x2 minus x1 gives me 2 minus 0, and this will give me 4 divided by 2, which is equal to 2. So this is the rate of change of function a. We're going to have a slope of 2. And now I look at this line here, and I could use this formula all over again, or I could just count the rise over run. And notice that I have to rise. I'm going up 2, 4, 6. So I'm going up 6, but I'm going over 2, 4 like this. So I'm rising 6 and I'm running 4. And if I simplify this, so dividing the top and bottom by 2, this simplifies to 3 over 2. Or I could say 3 over 2 is equal to 1.5 or 1.5. So when we compare these two slopes here, we could see that function a has a greater slope than function b. So the rate of change for function a is greater than the rate of change for function b. Question 35, we want to know which statement about the value of square root 50 is true. And right away, I could see we're going to eliminate choices B and C. I know this number is going to be irrational because 50 is not a perfect square. Just know anytime you take the square root of something that's not a perfect square, it's automatically irrational. And now out of the remaining answer choices here, we could eliminate A. And the reason being is that if we had a decimal that repeats, that would be a rational number. So I think of something like 13 over 99. Notice this is a rational number because it's a fraction where the top and bottom are both integers. And the bottom here is non-zero. And if I were to expand this as a decimal, this would be 0.1313 repeating like this. So this would be a repeating decimal, but this is clearly a rational number. But this answer choice here is golden because our number is irrational because the decimal equivalent is non-repeating and does not terminate. So choice D is our solution. Question 36, which graph represents y as a function of x? So for this one here, we just need to use the vertical line test. If you want to determine if your graph is a function of x, you need to use the vertical line test. And right away, I could see choice A is no good because when I draw the vertical line strategically, it hits the graph in two locations like this. So this would not be a function of x. Now, don't say, oh, I drew a line over here and it missed. You have to try to draw the line strategically and see if you could hit the graph in two locations. So choice C is also no good because there's our vertical line hitting the graph twice. So this one's out. Choice B is absolutely the worst because if you draw a vertical line through the vertical line, it's going to hit that vertical line infinite times. So this is really not a function of x. So choice D would be our solution. Notice this would be the equation y equals 3. And if I wanted to write this as a function of x, I could say that f of x is equal to 3. Question 37, we have a cylindrical container. It has a height of 56 centimeters, a diameter of 22 centimeters. We want to know what is the volume in cubic centimeters of the container in terms of pi. So for this, we need the formula volume equals pi r squared times h, and we'll draw out the cylinder. So here's the cylinder. We're told the height is 56 centimeters. So I'll just write the 56 without the units because the answer choices don't have the units attached. And the radius is going to be half the diameter. So if the diameter is 22 centimeters, just divide it by 2. The radius is 11 centimeters. So we'll put the 11 here, but once again, we'll leave the units out because the answers don't have units attached. So volume equals pi times the radius is 11. So we're going to plug that in and square it, and the height is 56. And once again, they're telling us the volume is in cubic centimeters. If you want to write that at the end, you can, but it's multiple choice. So the units are not going to matter towards the credit for our answer. So now we type everything in. We've got 11 squared times 56, and we're writing our answer in terms of pi. So I'm not going to attach the pi. If they told us to round, then I would multiply by pi at the end. And this would be our answer if we had to round to the nearest tenth or hundredth. But here's going to be our coefficient of pi. So now we'll just record our answer. 11 squared times 56 was 6,776. And now we tack on the pi, cubic centimeters, and this is going to match up with choice C. So question 38, we have quadrilateral ABCD is graphed on the coordinate plane with point C located at -4, 3. And we're told that we're reflecting this quadrilateral over the y-axis to create the image A prime, B prime, C prime, D prime. And then after the reflection, what are the coordinates of point C prime? So for this one, all you need to do here, if you have the formula memorized, just know that when you take the point -4, 3 and you reflect it over the y-axis, so we're going to reflect this over the y-axis, the way you do that is you just change the sign of the x. So we would change this from negative to positive, and this would match up with choice A. But me personally, I can't memorize these formulas. So what I would do here is I would just plot this point, negative 4, 3. So I'm just going to sketch this out here. Negative 4, 3 would be over here, and this is point C. And then we're reflecting this over the y-axis. We'll just make that a little bit neater. So point C is over here. We're reflecting this over the y-axis. So we would count to the y-axis. We would go 1, 2, 3, 4. And then we would go 1, 2, 3, 4 this way like this. So think about what are the new location here. Well, what's the new location of the point C prime? Well, we're going to the right 4 and up 3. So this would be the point 4, 3, which would still match choice A. So for question 39, this question is so easy it's difficult. We want to solve for the value of x in this equation, x to the third equals 125. Just know the opposite of raising something to the third power is taking the cube root of it. So if we take the cube root of both sides, that's going to tell us what x is equal to. And x is equal to the cube root of 125, which would be equal to 5. So this, if I wanted to do in my head, how do I know that this is correct? This is the cube root of 125 because if I raise 5 to the third power or multiply it by itself 3 times, this would give us 125. So this answer checks out. But we also get a calculator, so I could just press math and then option 4 is cube root like this. And I just type in 125 like this, and that would give me an answer of 5. Just know I could also press math. Option 5 is, notice there's an x in front of the radical. So if I were to select that option, then I just have to manually input the 3 to represent the cube root. And I could do the cube root of 125 is also 5. Either way, our solution is x equals 5. Question 40, we have triangle DEF. It's a right triangle with the right angle at vertex F. So the first thing I'll do is draw out a right triangle, and I'm going to label the right angle with the letter F. So there's our right angle over here. And we're told side DF has a length of 9 inches. So we'll call this over here DF. It has a length of 9 inches. And we're told that FE has a length of 12 inches. So I'm just going to put the 12 over here. We want to know what is the length in inches of side DE. So for this question here, there is a few different ways that we could do this. The fanciest way to do this would be to use similar triangle concepts. If you know your Pythagorean triples, you may recognize this as a multiple of a 3, 4, 5 right triangle. If we were to use a dilation here with a scale factor of 3, just imagine here I multiply every side length by 3. Watch what that gives us. This is going to give us, we're going to have 3 times 3 is 9, 4 times 3 is 12, and the mystery side is 5 times 3, which will be equal to 15 like this. So that's a really cool way here to find that the length of DE, I'm just going to make that a little bit neater, but DE is going to be equal to 15 inches. So this is the length of side DE. But probably the most reliable way to do this is to use the Pythagorean theorem. So we have a squared plus b squared is equal to c squared. And we could say here that the hypotenuse is going to be length c. And then if I just plug into the formula, let's say this is equal to a, I would have 9 squared plus b we'll say is 12, so plus 12 squared is equal to c squared, and that would give you 81 plus 144 is equal to c squared. And then 81 plus 144 is 225, and that would be equal to c squared. And then to solve for c, we take the square root of both sides, and that would tell us c is equal to the square root of 225, which is 15. But in either case here, DE is going to be 15 inches. Question 41, we have this equation below, and we want to know what is the value of x. So when I see this equation, I see everything that's attached to x, and I think about what is the opposite operation that I need to do to get x by itself. So the thing that stands out first is the minus 8. So to get rid of that minus 8, we could do plus 8 to both sides. Because on the left side, minus 8 plus 8 will cancel out because these are opposites. And then on the right side, we're going to have 20 plus 8 is 28. So we just write our 28. And then the minus 5x that's left is just going to follow down like this. So now we have minus 5x left. To solve for x, this is minus 5 times x. The opposite of multiplying by minus 5 is dividing by minus 5. So that's what we're going to do here. We're going to divide both sides by minus 5. And now we're going to have x equals. And if we want to do this math here on the side, we could use a calculator, but this isn't too bad. 5 goes into 28. 5 times 5 is 25. We subtract here. We have a remainder of 3. I could put a 0.0 here and put a decimal up here. And then I'm going to carry down this 0 like this. And then 5 goes into 30 6 times. 6 times 5 is exactly 30. So we have no more remainder. So x would be equal to, but just be careful, a positive divided by a negative is negative. We're going to have negative 5.6. And this is our solution to 41. So let's just record our answer, negative 5.6. Question 42, we have triangle XYZ and its congruent image, triangle X prime, Y prime, Z prime, shown on the coordinate plane below. So now for the actual question, we need to describe a sequence of transformations that maps triangle XYZ onto triangle X prime, Y prime, Z prime, and we need to explain our answer. So for this one here, I'm looking at point Z and thinking, how could it get to point Z prime? Another thing that jumps out at me here is that to get from this triangle to this triangle, at some point I have to flip, because I noticed that this point is in the bottom right corner, but in this location over here, it's in the top right corner. So right away I could see that we need to reflect over the x-axis. So we would need to go down 2 units this way if we're reflecting over the x-axis, and then go another 2 units this way. So see, if I reflect point Z over the x-axis, I would land here. But then think about, how do I get from here to Z prime? I would have to go over 1, 2, 3, and I would have to go down 2 units. So the transformations that we're going to use here, we're going to reflect over the x-axis, and then we're going to translate 3 units right and 2 units down. Now, one thing I would do here to be 100% sure that our sequence of transformations is good is I take the point X and I'm going to follow this sequence of transformations. I'm going to reflect it over the X-axis. So I would go down 2 units and then down another 2 units like this. And let's see if this translation brings us to X prime. We're going over 1, 2, 3, and we're going down 2 like this. And you could guarantee that if we do this for Y, we're going to map to Y prime. So we'll reflect over the X. So we're going to go down 5 to the X. So we have to go down another 5 to get to the reflection over the x-axis. And then from here, we're going 1, 2, 3 to the right and 2 units down. So you could see that following the sequence maps Y to Y prime. So this sequence is definitely good. Question 43, we're solving another equation. We want to know what value of x makes this equation shown below true. So for this one here, we have something a little bit more complicated than before, because now we have x's on both sides. So we just have to approach this very carefully. Now, the first piece that jumps out at me is the parentheses here. I just think of order of operations, and it's the same thing with solving equations. I try to take care of the parentheses first. So I'm going to distribute the 3 here. So I'm doing 3 times 5x, which is 15x, because I'm just doing 3 times 5 is 15, and the x tags along. And then I'm doing plus, we have 3 times 21, and 3 times 21 is 63. And then I could tack on the minus 9 over here like this. And then the 24x plus 33 just tags along. So then from here, I combine like terms. 63 minus 9 is going to give us 54. So this is going to simplify to 54 on the right, and everything else just carries down like this. So we have 24x plus 33 on the left side. That's just following. And now from here, I need to get the x's to one side. So I would do minus 15x on both sides of this equation like this. So we're just subtracting 15x. And now this term here will cancel out on the right. And we're left with 24 minus 15 gives us 9. So we have 9x plus 33 is equal to, we have 54 left. And now subtract 33 on both sides. And we just have to simplify. We've got 9x left on the left side. And 54 minus 33, if we do the subtraction, is going to give us 21. So now I'll just write the result over here. We have 9x equals 21. And then from here, just divide both sides by 9. So now we have x equals, and this I would just reduce. I would divide the top and bottom by 3. And 21 over 3 is 7. And then 9 divided by 3 is 3. So x equals 7/3 would be our solution. So x equals 7/3. Now just know there's a few other ways we could write our answer. We could actually divide here and say 3 goes into 7 twice with the remainder of 1. So 2 1/3 would also be acceptable for us to write our answer like this. Or we could even say 2.3 repeating like this, because 1/3 is just equal to 0.3 repeating. So either one of these answer forms would be fine. Question 44, we have triangle RST has side lengths 8 centimeters, 10 centimeters, and 13 centimeters. Is triangle RST a right triangle? We need to include what we know about Pythagorean theorem in our answer. Explain how you determined your answer. So for this one here, just know the Pythagorean theorem, we have a squared plus b squared is equal to c squared. So the only way that these 3 sides could make up a right triangle would be if they satisfied the Pythagorean theorem. So let's say I plug into this. I would have 8 squared plus 10 squared, and then we're going to set this equal to 13 squared. So if these 3 sides make up the sides of a right triangle, they would satisfy this equation. But watch what happens. We're going to get 64 plus 100 equals 169, which would tell us 164 equals 169. This is not true. Okay, so these are not true here. None of these equations are true, which tells us that these three sides cannot make up a right triangle. So this explanation here would be perfectly valid. If we want to say it once more, that 8 squared plus 10 squared is not equal to 13 squared, this would be sufficient here to say that triangle RST is not a right triangle. So question 45, we have function A and function B are shown below. We want to know which function has a greater rate of change, and we have to be sure to include the rate of change for each function in our answer, and we're going to explain how we determined our answer. So for this one here, we need to know this formula. The slope m equals y2 minus y1 over x2 minus x1. And just know this represents the slope between 2 points, the points being x1, y1 and x2, y2. So for the first function, function A here, we're going to find the rate of change using this formula. So just imagine instead that I had these last 2 points here written in the form 2 comma 12, and then we had 4 comma 24 like this. I could label this as x1, y1, and I could label this point as x2, y2. Just know I could find the slope between any 2 points, but I'm picking these because their numbers are nice. They're positive numbers. They'll be easy to work with. So we find the slope here. So we're going to do y2 minus y1. So we're doing 24 minus 12 divided by x2 minus x1 would give us 4 minus 2. And then we just have to simplify. 24 minus 12 is 12, and 4 minus 2 is 2, and 12 divided by 2 is equal to 6. So the rate of change of function A is equal to 6. Now for this one, this is the point 0, 0, and this is the point over here, 6, 3 like this. So if I find the slope between those 2 points, I can label this one as x1, y1, and I'll label this point over here as x2, y2. I'm going to do 3 minus 0 divided by 6 minus 0. Okay, so I'm doing the difference of the y values divided by the difference of the x values. And this gives me 3 divided by 6, and that simplifies to a half. So which function has the greater rate of change? Well, function A has the greater rate of change because the slope 6 beats the slope 1/2. Now, before we move on, just know we only have to find the slope between 2 points because function A represents a linear function here because the rate of change is not changing at all from one point to the next. And just know here, this might be a little bit extra, but they said explain how you determined your answer. So that extra sentence I wrote just explained that I used the slope formula to determine the answer. So question 46, we have a trampoline. It's in the shape of a circle. The diameter is 12 feet. What is the area in square feet of the top circular surface of the trampoline? So for this one, we need the formula area equals pi r squared. That's the formula for the area of a circle. So if this is our trampoline, we're told the diameter. So we just have to be a little bit careful here. Be careful not to say pi times 12 squared. This would be a very, very dangerous bear trap. What you want to think about instead here is that the diameter is 12 feet, so the radius would be 12 divided by 2, or it would be equal to 6 feet like this. Okay, so that's our radius, 6 feet. And if you think about it, if I label each of these as 6 feet, you can see the distance from one end to the other would be 12 feet, which would represent the diameter. So now I just plug in. I have pi times, and I have 6 feet, and I'm squaring it like this. So the area equals, we have pi, so we're going to press second and then this up arrow here to get the pi. And it was 6 squared, so we're just going to tack on 6 squared like this. And then 36 times pi gives us this number. So the area equals 113.097, and the units are square feet. But remember, they told us to round to the nearest whole number. So looking at this, we could say the area equals 113 because to the right of the ones place here is a 0. So we're going to be rounding this down to 113. So 113 square feet. So let's just record our answer, 113 square feet. Question 47, we have a student claims that these expressions are equivalent. Is the student correct? And we need to be sure to include what we know about properties of exponents and the value of each expression in simplest form in our answer. We have to explain how we determined our answer. So for this one, I'm looking at 5 to the 7 divided by 5 to the 3rd. And I know by the division property of exponents that I could simplify this by doing 5 to the 7 minus 3, which would give me 5 to the 4th power. And if I wanted to expand this here, just thinking in my head, I'm doing 5 times itself 4 times. So 5 times 5 times 5 times 5 would give me, well, this would give me 25 times another 5 is 125. This would give me 625. So this works out to 625. And now if I simplify the other one, I'll do that over here. If I were to do 5 to the 6 times 5 to the negative 2, using the multiplication property of exponents, I just add those exponents together. I'd have 6 plus negative 2. And then 6 plus negative 2 gives us 4, and 5 to the 4th power, once again, is equal to 625. So these expressions are equivalent. The student is correct. So question 48, our last question, we have 3 different functions represented by an equation, table, and graph. We want to determine whether each function is linear or nonlinear. We have to be sure to include what we know about the properties of all 3 functions in our answer. So looking at function A, notice that it's in the form y equals mx plus b, where m and b are constants. Remember, m represents the slope and b represents the y-intercept. But this is in that form here, so function A is definitely linear. So this is linear because it's in the form y equals mx plus b. Now looking at function b, what I want to check here is to see if the rate of change is constant, because notice when you have a line that to get from one point to the next, you're going up and over by the same amount. That's why the points are forming a straight line. So when I look at this, I think of the formula y2 minus y1 over x2 minus x1. And if we find the slope between 2 points, let's say these 2 points here, I use the slope formula. I'm going to have 1 minus 0. So I'm subtracting the y values, and then I'm dividing by the difference of the x values. It would also be 1 minus 0. So the slope in this case would be equal to 1. But now let's see what happens when I find the slope between the next 2 set of points. So if I were to find the slope one more time, so we'll just go ahead and make some dividing lines here. If I find the slope again, this time between these 2 points, now I would have 4 minus 1 divided by 2 minus 1. And when I divide this time around, I have 4 minus 1 is 3 divided by 1, which is 3. So notice that the rate of change is not the same each time. We went from a slope of 1 to now we have a slope of 3. So this one here is nonlinear. Okay, so this is going to be nonlinear because the rate of change is not constant to get from one point to the next. Now this one here is the most obvious because you can see these points are forming a straight line. So we have a linear function. This one is definitely linear because the points form a straight line. The slope is not changing when we go from one point to the next. If we had to find the slope here, we could just count the rise over run. We're going up 1, 2, 3 over 1. So the slope of this line is 3 and the y-intercept is negative 4. So we could say this is the equation 3x minus 4, but all we have to comment on is what they gave us, and they gave us a graph. So just say the points form a straight line, so this is linear.